June 2022, Unit 5. We'll discuss MCQs today. This question is about the catalyst. As you can see, some standard electrode potentials are shown for copper, for iodine, for iron 3, chlorine. Which of these ions is most likely to catalyze the reaction? Yeah. How to identify the catalyst? First thing, because ions are there. If you see this thing, these two are negative ions. Okay. Yeah, these two are negative ions. If we have the negative ions, they will repel each other. And what should happen? The substance should easily be oxidized and reduced. To be a better catalyst, a homogeneous catalyst, it should be easily oxidized and reduced. So when we see copper 2 cannot be catalyst. Why? Copper 2 cannot be catalyst. Like, let's say, start with chloride. Chloride ion can only be oxidized, but it cannot be reduced because that is the maximum, that is the minimum number which it can have. So chlorine can change, the oxidation number of a chlorine can change from -1 to +7. So means it can be oxidized only, but it cannot be reduced. But to be a homogeneous catalyst, it must be oxidized or reduced. So it cannot be chlorine. If you see iron 2, iron 2 is there, Fe is +2 or 2 plus. So means Fe2 plus can form an iron Fe plus, like it can be reduced and it can be oxidized because one of the oxidation number is +2. Another one, like it can have +3 oxidation number, or it can have +1, or it can be iron as well. So it can be oxidized or reduced. So this can be an answer. Then copper is 2 plus. Copper maximum oxidation number is +2. So copper can only be reduced to +1 or 0, but it cannot be oxidized. So copper 2 cannot be a catalyst because to be a catalyst, a homogeneous catalyst, it must be oxidized or reduced. When we check copper 1 is there. Copper 1 can be oxidized to copper 2 +2, and it can be reduced to 0. So oxidation and reduction can happen. Now we check, like, so either copper 2 can be there, or copper 1 can be there, or iron 2. Then we check their oxidation numbers. Because the idea is that, I mean the electrode potential. The higher electrode potential is there. What does it mean? It will force the other to happen. Like it will have a greater tendency. But when you check the reaction here, so first we conclude that either iron 2 can be there or copper 1 can be there. Okay. Now, when we check with iron 2, so this is iron 2. And the reactants are thiosulfate and iodine. So one of the reactant is iodine, another reactant is a thiosulfate. So when the reaction happens between them, these two, if the reaction, like, because it can either react with this or the other one. So if it react with these two, which one will be reduced? But we have iron 2. So means in this case, this will have a reduction because higher is there. It is a red minus ox. But we don't have iron 3, we have iron 2. When we check these two, so here what will happen? The higher electrode potential, so this will be a reduction and this will be an oxidation. So means first what will happen when S2O8 will react with iron 2, because we have iron 2. So first when it react with iron 2, it will form SO4 and it will form iron 3. That is the first reaction. And then what will happen? Can a reaction happen between iron 3 and iodide? Then we will check. If we check the second reaction between them, so what will happen? Because this is having a higher oxidation number, so this will be a reduction happen and this will be oxidation happen. So means in this case, a reduction happens. So the iron 3 will react. It will be reduced to iron 2 because it has a higher oxidation number. Yes, Hashim, I'll answer your question. Just a minute. Iron 3 is there, reduced to iron 2, and iodide ion, because iodide ion is there, that will be oxidized. So iodide ion will turn into iodine molecule. So means, because if it's a homogeneous catalyst, it should, first case, it will be either oxidized, and another case, it should be reduced. Or if first is reduced, other is oxidized. So first iron 2 will be oxidized to iron 3, and then the iron 3 will be oxidized, reduced to iron 2. So we'll get the same iron 2 back again. It means iron 2 should be a catalyst. Why copper 2 cannot be a catalyst? Because to be a catalyst, it should be oxidized and reduced. But the copper oxidation number is +1 or copper 0. So it cannot be, it can only be reduced but not oxidized. That oxidation number which is given to us must be oxidized or reduced. Like chlorine can be oxidized but not reduced. Copper can be reduced but not oxidized. Copper 2 ion. Like you cannot get a higher number than +2. So it can only reduce but not oxidize. But what should happen? To be a catalyst, like iron 2 can be iron 3, it means oxidation can happen, or it can be iron +1 or 0, it means it can, reduction can also happen. For copper 1, it can be +2, oxidation happen, or it can be 0, reduction can happen. So that's why we check. So with copper, with iron 2, first it react with the thiosulfate, it will be oxidized to iron 3, and then the iron 3 react with iodide ion to form iron 2. So B is the answer. But why not C when we check with the copper? Let's now check with the copper. So this is the equation called copper. This is iodine and thiosulfate. Now let's see. Because first we have a copper 2 ion. So first we have a copper 2 ion. So copper 2 ion should be reduced. So if we check these two equations, this will be reduced and this should be oxidized. So means this will not happen. When we check the second equation with the second reaction, this will be reduced and this will be oxidized. But here is a reduction. We want it to be a reduction, not oxidation. So means the copper 2 ion, or when we check the copper 1, like these are the equations. So you have copper 1 according to a question. So when we check these two, this will be a reduction, this will be oxidation. So first what will happen? Iodide ion is there. When it react with copper 1, what it will form? It will form iodine molecule and it will form copper 2 +2 because oxidation happened. Then now copper 2 you have. So now you have a copper 2 and you want to react a copper 2 with S2O4. So copper 2 and S2O8. So what will be the equation for them? Like if you compare this with this, so this one reduction should happen. And this one oxidation happen. If oxidation happen for copper 2, so means it should be copper 3, but there is no copper 3. So that's why the second reaction cannot proceed. Is it clear?
Sir, how's the last reaction reduction between copper 2 and S2O4?
S2O8
I mean, oxidation.
cannot happen.
Wait, sorry.
Why? Yeah,
Why?
why it cannot happen? Because S2O8 and copper 2, check the electrode potential. Here, this is 0.7 and this is 2 positive. So which one reduction will happen? The higher one reduction. So means this will be reduced. If this is reduced, this must be
The plus 2.
oxidized.
Yeah.
So if copper 2 is there, if copper 2 is there, it should become copper 3. But there is no copper 3. Copper 3 is not their existing oxidation state. Clear?
Yeah.
So what you have to check to identify, first thing you will see whether it can be oxidized or reduced. So the iron 3 can be oxidized and reduced, and copper 1 can be oxidized or reduced. But the problem with copper 1, that copper 1 can react with iodide here. So this will reduction happen, this will oxidation happen. Means this will go forward, this will go backward. And then the copper 2 ion which is produced has to react with this substance. And the copper 2 ion must be reduced. But when we check this electrode potential with this one, the copper 2 ions will further oxidize. It should form copper 3. But copper 3 is not an existing state. That's why this cannot be used as a catalyst. To be
Sir,
a
but
catalyst, it must be oxidized and reduced.
what if copper 1 ion reacts with S2O8 at first?
If it react with, yes, if you react with this one, same thing, same answer will get. Like if you see these two. So first, what should happen? This is having a higher electrode potential, so this should have a reduction happen. So this will be oxidation happen. Okay. So what we will have, we'll have a copper 1 ion, and it is S2O8.
Yeah, it's still less. Yeah, it's still less. Got it.
So it will form SO4 and it will form copper 2. That's formed. Now you have a copper 2 ion. Now this copper 2 ion must be reduced with iodide. But when you check this electrode potential, you found that this is less than iodine. So means this should be a reduction and this should be oxidation happen. Like copper 2 ion cannot be reduced by the iodide.
Yeah. Got
Got
it.
it?
Got it.
So this has to be reduced and this has to be, but we want iodide as the reaction can occur between iodine molecule and a copper 1 ion, not copper 2 ion. Then describe a term for catalyst. It's a homogeneous catalyst. Why? Because the catalyst will have the same state as the reactant. When ions are there, homogeneous catalyst. When you have a solid, then it will be a heterogeneous. Which substance is manufactured in a process involving a reaction catalyzed by vanadium? So we manufacture vanadium pentoxide is for sulfuric acid because sulfur trioxide is there. A straightforward question. The next is, this question is about alkaline hydrogen fuel cell. What is a half equation at negative electrode? If we have a fuel cell, a normal fuel cell is there. So one side hydrogen is added. So hydrogen will turn into hydrogen ions and it will lose electron and these electron will travel. And in a chemical reaction, look, don't be confused with a negative electrode. And two things are different. One is a negative electrode, another one is a cathode. According to electrolysis concept, like if we have a cell is connected and we have a positive anode is there, the one which is connected with a positive terminal and one which is connected with a negative terminal is cathode. So always the positive ions will move towards the cathode and they will gain electron. Gain electron means reduction happen at cathode. And at anode, the negative ion will move there and will lose electron. So oxidation happen at anode. So at cathode, one is cathode and anode in terms of oxidation and reduction. So here what happened, hydrogen is losing electron. If hydrogen is losing electron, so which electrode is this? This is an anode. Why? Because it's a loss of electron. So oxidation happens. So which electrode? Oxidation happen is an anode and the other one will be a cathode. This is anode and cathode. But which is a negative terminal? In a chemical cell, the one which is having more electron, because hydrogen will lose electrons, so majority of electrons will be here initially. So this is a negative electrode and this is a positive electrode. Okay, so in a chemical cell, the anode itself is a negative electrode and cathode is a positive electrode. It's a bit different from the electrolysis cell. In a chemical cell, anode is reference to the oxidation and reduction. So because here oxidation happens, so that's why it is anode, and reduction happens, that is why it is cathode. But in terms of the movement of electron, the negative one where the electron is being lost in a chemical cell. So this, remember, the anode in a chemical cell is a negative one and cathode in a chemical cell is a positive one. So we want to identify which one happened at a negative electrode. So negative electrode means there must be a loss of electron. So which one is losing electron? Which case the electron is lost? So this is the loss of electron. Like either A can be an answer or D can be an answer. But because as you can see, this is one of the answer or this can be an answer. But in a fuel cell, what we use hydrogen. So hydrogen is there, and it's an alkaline fuel cell, means it contains a hydroxide ion. So at anode the hydrogen is added, at cathode oxygen is added. So that's why the hydrogen in alkaline condition, presence of OH, will form a water and gives 2 electrons. So A will be the right answer. Why not D? D just shows the alkaline condition, but it does not show the reactant. And this actually happen at the other electrode. Reverse happen where oxygen combined with water will take 4 electron and form hydroxide ion. Is it clear, the fuel cell?
Yes, sir.
Then part B, which statement is correct for alkaline hydrogen fuel cell when compared with acidic hydrogen fuel cell? Acidic and alkaline hydrogen fuel cell, both the reactants are water and oxygen, hydrogen and oxygen to give off water. So electrode potential of a cell will be same. Because the particles are same, so entropy will also be same. Kc will also be same. The only thing, the catalyst, because in alkaline hydrogen fuel cell, when we compare, the catalyst is more efficient in breaking down or producing the breaking down the hydrogen molecule into hydrogen ion. So only thing, the catalyst, because the reactants are same, so the product is also same. So there is no change in the electrode potential of a cell or total entropy or Kc. The only thing that the comparison is the catalyst. The rate of the reaction for alkaline fuel cell is much higher as compared to acidic fuel cells. Excess of a sodium thiosulfate is added to an excess of ammonium vanadate 5. What color is a mixture when the complete reaction have happened? Refer to a data booklet. Okay. So what we have to do, we have to check the reaction between a thiosulfate and a vanadate 5 ion. Like what is the final oxidation number? So just a minute, I'll open the data booklet.
Sir, in the meanwhile, I just want to ask a question in
Yes,
question 2B. You said that which one will be a more efficient catalyst during acidic condition or alkaline?
The alkaline condition.
Why?
Because in alkaline conditions, we use, there is a substance which we call a semi-permeable is there, membrane, which is allowing the hydroxide ions are acting as a catalyst, which already contain a greater, like KOH is there in between. So what actually happened, the hydrogen which we add from here break down into hydrogen ions. In this alkaline condition, the hydrogen ion move faster. Because in acidic condition, why these hydrogen ions cannot move faster? Because the electrodes are made up of, the electrolyte is an acid. And an acid already have a protons, H plus ions are there. So these H plus ions repel each other. Like already, like any acid is there, let's say sulfuric acid or a hydrochloric acid is there. So already H plus ions are there. So when this hydrogen molecule break down, it produce hydrogen ions. These hydrogen ions repel the hydrogen ions entering the electrolyte. That's why they move slowly. But the hydroxide ions are negative ions, so they attract the hydrogen ions, so they move at a higher rate. And on the other side, oxygen combined with this hydrogen ion, hydroxide ion, and produce a water molecule. Clear?
Yeah, understood.
So main reason is because the H plus ion is being repelled by the proton of the acid, which were used as electrolyte. Like catalyst, I mean. So we have to check the page 10 of the data booklet and work out the final color. Actually, this is my one is an old data booklet. So I just need an electrode potential. Here we have electrode potential.
I have the new answer. If you want, I can send it.
Yeah, if you
over.
can send, that will be good. But I will
Okay.
use this now. I will use this now. So
Sure.
actually,
Okay.
but send it to me. I will open that one later. Now, actually, what we have to do, we have to
Okay.
find what is the final oxidation number. Okay. And what are the reactants here? The thiosulfate and vanadium 5. So thiosulfate, where is thiosulfate? Here is thiosulfate. The electrode potential is 0.09. Okay. And vanadium 5, vanadium have different oxidation number. I can use this as well, which will be much more easier to thiosulfate in this one. These are the standard electrode potentials. Reduction potential, I will use vanadium. This one. Send the latest data booklet, because otherwise I have to read through each of them to know. Because they
Okay.
already mentioned it's on page 10, so I will directly move to page 10.
Okay, sir.
Okay. Page 10 refers to page 10 of a data booklet. This is the same looks. Oh, page 5 is this. Page 10. Okay, this is a page 10, but page 10 is affinities are given. So I have to use this. No problem. Thiosulfate, when I write, you see the thiosulfate electrode potential is given 0.09, and vanadium is there. Yeah, this is a thiosulfate. Sodium thiosulfate and ammonium vanadate. Means vanadium is 5.